Now we're going to discuss a rate expression, and we're going to consider it for a reaction where you have 2 moles of reactant A that disappear for each 1 mole of reactant B that is formed. So previously we saw the delta, or the change in concentration over the change in time. So our rate with respect to A is the change in A over the change in time, and it's negative because it's a reactant and it will be decreasing. The rate of the reaction, however, is the change in concentration of A over the change in time. So the rate of A now divided by its stoichiometric coefficient. The rate of B is the change in the concentration of B over the change in time. And the rate of reaction is the same because it has a coefficient of 1. So when you divide by 1, it's the same thing. So both of these represent the rate of reaction, and we can set them equal to each other. So a rate expression in general, you can take your reaction and express the rate of reaction in terms of each species in the reaction. So in this generic reaction, the lowercase letters are the coefficients and the capital letters are the reactants and products. So we have the rate with respect to A divided by its coefficient equal to the rate with respect to B divided by its coefficient. Both of these have negatives because they are reactants, and they will equal the rate with respect to C divided by its coefficient equal to the rate with respect to D divided by its coefficient. So this gives the overall rate of the reaction with respect to each reactant and its stoichiometry.